Hi everyone, thanks very much for attending my presentation. I'm Dizeng from East China Normal University. My report is about partitioning, extirpation, and colonization components of avian beta diversity on land bridge islands. As we know, biodiversity change and its underlying mechanisms is critical for us to understand the biodiversity maintenance under global changes. The space and time are two fundamental axes of beta diversity changes. From the spatial and temporal perspective, we could better understand the potential effects of habitat disturbance, climate changes, and biological invasions on biodiversity changes. As an essential method to assess the biodiversity change, beta diversity attracts many focus recently. Beta diversity could reflect the differences in community composition. Considering the changes in beta diversity along the habitat disturbance would shed light on the underlying mechanisms of community assembly under habitat disturbance. Species extinction and colonization are two basic processes to alter the beta diversity, which could be impacted by habitat disturbance and lead to different patterns of beta diversity changes. For example, some researchers have compared the beta diversity changes before and after habitat disturbance and further partitioned the roles of dynamics of extinction and colonization of species. They demonstrated that species colonization and extinction could cancel each other, leading to non-significant change of beta diversity. Furthermore, they also showed that the role of species extinction and colonization on change of beta diversity could change after habitat disturbance. Therefore, analyzing beta diversity changes and the relative roles of species extinction and colonization along the habitat disturbance are critical to shed light on how habitat disturbance impact our biodiversity trends. Although the roles of extinction and colonization in changing beta diversity could be changed by habitat disturbance, we still have few empirical studies conducting detailed assessments on the consequences of extinction and colonization dynamics on beta diversity along the gradients of habitat disturbance. Here, we conducted our study in the Southern Island Lake, China, a land bridge island system created by dam constructions. The Southern Island Lake has more than 1,000 islands with a gradient of area and isolation, which provides a good chance to test the effects of habitat changes and disturbance on beta diversity change and the potential roles of extinction and colonization dynamics. We chose the 36 islands with gradients of area and isolation as our study sites. The present analysis was based on a long-term bird survey in our study islands. All the observed and heard birds were recorded along the transect line on each study island. We chose bird community data of two survey periods, spanning 10 years. To assess the temporal changes in beta diversity and the potential roles of extinction and colonization, we use a new beta diversity partitioning method proposed recently. This method calculates the net temporal changes in spatial beta diversity and further partitions these changes into 6 components of species colonization and extinction. Based on this method, we have two aims. First, we assess the multi-size beta diversity to find the overall pattern of beta diversity change across 10 years in our system. Second, we use the pairwise beta diversity to assess the effects of the area and isolation on the colonization and extinction resultant beta diversity changes. The multi-site beta diversity analysis showed that the overall beta diversity among 36 islands increased caused by species colonization. The further partitioning shows that the extinction and colonization both cause the beta diversity increase and decrease. But extinction mainly caused beta diversity decrease, and the colonization mainly led to the increase of beta diversity. For pairwise beta diversity, we didn't find any significant relationship between pairwise beta diversity and differences in island area and inner distance between pairwise islands. The potential reason might be that, for area effects, there might be a simultaneously colonization and extinction processes, which might unmask each other and lead to no change in pairwise beta diversity along the difference in area between pairwise islands. This is also verified by further partitioning results. For non-significant isolation effects, higher dispersibility of birds and a small geographic scales of our system might be the potential reasons. We further partitioning the pairwise temporal beta diversity changes into 6 components representing the dynamics of extinction and colonization. Here, we only show the significant results. First, we found that beta diversity decrease caused by extinction of unique species on other pairwise islands was enhanced between similar-sized islands. The potential reason might be that some suitable habitat loss due to habitat loss and fragmentation in our system might lead to local extinction of some specialist birds. Moreover, almost the islands pair were smaller islands in our system. Therefore, the effects of suitable habitat loss would be higher in similar-sized islands, which might cause more loss of rare species and higher beta diversity loss. In addition, we also found beta diversity increase caused by loss of shared species on both pairwise islands was also enhanced between similar-sized islands. The reason might be that habitat loss and fragmentation in our system might impact some regionally abundant species due to trade-off between disturbance tolerance and other abilities, such as computation or dispersal. Therefore, the pairwise islands with similar area which are almost small would cause the loss of some generalist species and lead to higher beta diversity increase. Similarly, beta diversity decrease by colonization of existing species on other islands also improved between similar-sized islands. This might be due to habitat homogenization after habitat loss and fragmentation, or stepping stone effects because of small inner distance between islands in our system. This might enhance the dispersal of some rare species and cause higher beta diversity loss. Overall, our results show that, first, beta diversity increased across 10 years in the southern island Lake China, which might due to species colonization. Second, extinction and colonization resulting beta diversity components could mask each other and lead to no significant total beta diversity change along the gradients of habitat disturbance. Third, partitioning different extinction and colonization dynamics could provide more insights on temporal changes in beta diversity along the habitat disturbance. Finally, I will acknowledge to my PhD supervisor, Dr. Ping Ding in Zhejiang University, China, and my current collaborator advisor, Dr. Xingfeng Si, my colleague Dr. Yuhao Zhao, and other team members in East China Normal University. I also thank the National Natural Science Foundation of China, as well as the ATBC 2022 for this opportunity to share our work. That's all. Many thanks to everyone to attend my presentation. Please let me know if you have any questions.